Welcome to the DIY Honda Garage channel. DTC P0720 indicates a malfunction in the output shaft or countershaft speed sensor circuit on the Honda Fit models from 2015 to 2020. This sensor plays a critical role in the vehicle's operation by providing information about the rotation speed of the output shaft, which is vital for transmission control. The sensor is typically located on the transmission and is responsible for relaying data to the powertrain control module, PCM. The malfunction may lead to issues with vehicle speed detection, affecting transmission performance. Regular monitoring of diagnostic trouble codes like P0720 can prevent serious complications and maintain optimal performance. DTC P0720 refers specifically to a malfunction regarding the output shaft or countershaft speed sensor circuit. This sensor is crucial in determining the speed at which the output shaft of the transmission is rotating. By sending this data to the PCM, it helps in managing transmission shifts effectively. Located on the side of the transmission, this sensor is wired to the PCM through a 3P connector. Issues with this circuit may result from wiring problems, sensor failure, or communication errors, thereby causing erratic vehicle performance when operating at different speeds. Several issues could lead to DTC P0720 appearing. One possible cause includes poor electronic connections, which might manifest as loose terminals at either the output shaft speed sensor or the PCM. A faulty speed sensor could also be to blame, as it may cease to transmit speed data accurately. Additionally, wiring issues in the circuit, such as open or shorted wires, could also trigger this code. Each of these causes needs to be investigated thoroughly during the troubleshooting process to isolate the exact fault. Detecting these problems early can prevent further damage and expensive repairs. The symptoms linked to DTC P0720 can significantly affect driving experience. One of the most noticeable symptoms is erratic speedometer readings, where the speeds displayed do not match the actual speed of the vehicle. This can lead to confusion for the driver, affecting their ability to control the vehicle effectively. Additionally, transmission shifting problems may arise, where the vehicle struggles to shift gears correctly, impacting acceleration and overall performance. In severe cases, the vehicle might experience engine stalling while driving, leading to increased safety risks. Monitoring these symptoms can help diagnose and rectify issues related to this DTC quickly. The first troubleshooting step for DTC P0720 involves problem verification. Start by starting the engine and holding the engine speed at 3,000 RPM without load until the radiator fan engages, and then allowing it to idle. This process helps to recreate the conditions under which the DTC was triggered. After a few minutes of idling, perform a test drive to evaluate any anomalies in performance. Following the drive, check the C-shaft SPD value in the data list using the Honda Diagnostic System, HDS. If any vehicle speed is indicated during this check, it confirms an intermittent fault, prompting further inspection of connections around the output shaft speed sensor and PCM. The second troubleshooting step focuses on determining the possible failure area. Begin by turning the vehicle to the off mode, allowing the systems to reset. Disconnect the 3P connector from the output shaft speed sensor to prepare for voltage measurement. Once disconnected, switch the vehicle to on mode, ensuring that the ignition is on while the engine remains off. Measure the voltage across test points 1 and 2 within the sensor connector. This test will indicate if the output shaft speed sensor is receiving the expected voltage level, which should be around 5.0 V. The next steps will depend on whether the proper voltage is detected, In the third step, we conduct an open wire check of the VCC1 line. With the vehicle still in the on mode and the output shaft speed sensor unplugged, measure the voltage again at the designated test points within the sensor connector. This reading will help confirm whether the VCC1 wire is functioning correctly. If approximately 5.0 volts is noted, this indicates the VCC1 wire is operating as intended. Should the results show no voltage, there is an open circuit in the VCC1 wire between the PCM and the speed sensor. This will necessitate inspection of the wiring and potential repairs to restore the signal pathway, ensuring reliable sensor operation. Next, the fourth troubleshooting step involves determining the possible failure area concerning the output shaft speed sensor. Again, you measure the voltage at the designated test points with the 3P connector disconnected. This will assess the functionality of the output shaft speed sensor circuit, expecting to find a reading around 5.0 volts. If confirmed, indicates that the sensor is faulty and must be replaced. Following replacement, it's critical to reconnect the sensor and recheck the function. This verification process ensures that the new sensor resolves the P0720 issue effectively. In the fifth troubleshooting step, you address potential shorts in the wire circuit. First, turn the vehicle to the off-lock mode to ensure all systems are powered down. Use the Honda Diagnostic System, HDS, to jump the SCS line. Then disconnect the PCM connector C and check for continuity between the defined test points. This test verifies if there is an unwanted short circuit present between these critical connections in the system. If continuity is found, it indicates a short in the NC wire that connects the PCM and the output shaft speed sensor. Repairing this connection is essential to eliminate shorting issues that may hinder sensor performance. The final troubleshooting step involves checking for continuity within the NC line. With the vehicle in the off-lock mode and both the PCM connector and the output shaft speed sensor connector disconnected, you need to check for continuity between the specified test points. If continuity exists, it confirms that the NC wire is intact. In this case, you may need to update the PCM software, or if that doesn't solve the issue, substitute it with a known good PCM. If after these troubleshooting measures the P0720 code is cleared, you will be able to conclude whether the original PCM was the cause or if it was simply a software glitch. Final repair verification is an essential step to ensure all issues related to DTC P0720 have been addressed adequately. After completing all necessary repairs or replacements, it is crucial to run a diagnostic check to confirm that the DTC is no longer present. This step involves reviewing the vehicle's onboard diagnostics using the HDS to ensure no fault codes are lingering. It's equally important to test the vehicle's performance during a road test, checking for any anomalous behaviors like erratic speedometer readings or shifting issues. Successful completion of this verification confirms that the issue is resolved and the vehicle is operating correctly. Preventive maintenance plays a significant role in not only avoiding DTC P0720, but also enhancing vehicle reliability. Regular checks of the output shaft speed sensor should be conducted during routine services, which can reveal early signs of wear or malfunction. Additionally, inspecting wiring conditions for wear or corrosion is critical, as this can affect sensor performance. Keeping connectors clean and free from debris or moisture can prevent connection-related issues that may later lead to this code. Overall, implementing a strategy that emphasizes these preventive measures will significantly enhance the longevity and performance of the vehicle's transmission system. In conclusion, understanding DTC P0720 is vital for maintaining optimal performance in the Honda Fit models from 2015 to 2020. This code signifies a malfunction in the output shaft speed sensor circuit, which can have severe implications on transmission behavior. It is essential to recognize the various factors that can trigger this DTC, including wiring issues, faulty sensors, and connection problems. Utilizing the troubleshooting steps outlined can effectively identify and rectify these issues. Furthermore, the implementation of preventive maintenance strategies will minimize the risk of reoccurrence, ensuring that the vehicle remains in peak operating condition. By prioritizing these practices, vehicle owners can facilitate a safer and smoother driving experience. Please like and subscribe to the channel. See you next time.